Hello everyone, in this video I will be explaining you the problem minimum discards to balance inventory. So it was asked in LeetCode Biweekly Contest 165. So let's read out the problem. You are given two integers w and m and an integer array arrivals, where arrivals of I is the type of item arriving on I on day I. They are one indexed. Okay. Okay, it is one index, got it. So items are managed according to the following rules. Each arrival may be kept or discarded. An item may only be discarded on its arrival day. Okay, got it. So for each day I, consider the window of day, which is maximum of 1 comma I minus w plus 1 till I. The w most recent is up to day I. So don't worry, I'll be telling you what they're saying. So for any such window, each item type may appear at most m times among kept arrivals whose arrival day lies in that window. If keeping the arrival on day I would cause its type to appear more than m times in the window, that arrival must be discarded. So they are asking us to return the minimum number of arrivals to be discarded, so that every w day window contains at most m occurrence of each type. So okay, so they have given one of the example wherein you have items as 1 2 1 3 1, w is 4, m is 2. So let's take the example on the board and let's try to you know find the solution. So w is 4, m is 2, and arrivals, they are basically 1 2 1 3 and 1. So yeah, this is the arrival. Here what they're saying is each day it is one based indexing you can think of, like it is on day 1, item 2 arrives on day 2, item 1 again arrives on day 3. These are days, and item 3 arrives on day 5, day 4, and on day 5 item 1 arrives. So now the question is, in the window size of only 4, like when item arrives right on day 1, on like initially like it's we don't have any item, so on day 1 one item arrives, that is fine. And on day 2 again 2 item arrives, that is also fine. On day 3 3 item arrives, okay. On day 4 4 item arrives. So on 5th day if you try to take from 1 to 4, this is not the possible window. You need to remove the last window, because your window size cannot exceed w. So your window size has to be w only. So in the question whatever they have said, your window size will be max of you know um, 1 comma, it is 1 minus w plus I something, it was there uh, till I. So this is the window size, right? So which means whenever you are at this position, so you will be considering all the windows from backside. So since we don't have anything, so only one size window you will be having. When you are at day 2, so 2 size window you will be having. When you are at day 3, 3 size window you will be having. When you are at day 4, 4 side. But when you are at 5th day, your window size shouldn't exceed w. Your window size will be from day 2 to day 5. That is the main thing of this statement. I minus w plus 1. Sorry, I wrote some other way. I minus w plus 1. So this is the thing they are saying. And one more thing that what they are saying is that you'll have to find the whenever one day, so item 1 is present and it has occurred one time. So now you're taking 2 days window. So on day 2 item 2 arrives and it has occurred one time. On day 3 item 1 arrives, so now you take its frequency to be more, like you have two items of item 1 type. These are item 1 types and its numbers. Now on day 3 it may happen that like third item type arrives, its frequency is 1. So you're not discarding anything right now. But when you are moving to the next day, since your window is increasing, window will be 5, but you need to make it window 4. So just make the last from the left hand side, the window is small. So one item whatever it was present, you need to discard, decrease its occurrence by 1. And now you will be taking the 5th day, and the window has again this item is of type 1, so its frequency will be increased to 2. So in this case, if you see, you did not discard anything, because whatever frequency you had, it was within the range of 2, right? So now let's take the same example, and in this case, your discard answer is 0, right? Now let's try to take this same array, only one element I'll be changing, and you will understand properly. So this element I'll be changing it to 1 only. So now I'll be taking this on day 1, I'll be taking this element of type 1, and it has occurred 1 time. Now when I move to second day, its window is still 2, which is less than w, that is fine. So 2 item you will be taking, and it has occurred 1 time. Now when you're moving on day 3rd, so window size 3, which is lesser than w, that is fine. And one item you're taking, item of type 1 you're taking, so its frequency will be increased. Now when you move to this 4th day, your window is 4, which is lesser than equals to w, which is true. But if you see here, item 1 you're taking, and it's if you try to check the frequency of that item 1, you will see in the I'll be storing this in hash map. Basically your key will be item type, and value will be occurrence, basically frequency of that. So when you see that it is equals to m, so if you try to take this item, your frequency will be increased to 3. So that's why you should not be taking this element, because in the question they have said the frequency of the each item type has to be lesser than or equals to m, not more than n. If it happens to be that, like if you try to choose this element and if it happens to be more than m, so you just discard this element. So I'll be discarding that. So your frequency is 2 only, and in the discard, one variable I'll take. Basically in that I'll be initially it will be 0, I'll increase it by 1, which means this item I have discarded. Okay, and I'll be storing unordered set, and I'll be storing its index. This point I'll be telling you in the second example, or the example wherein okay, I'll be taking the second example or different example, I'll explain you. But right now it is clear, right? This element you can't take, you need to discard it. So that is fine. Now when you move to the 5th day, so your window size has increased, but before going to 5th day, so what you'll have to do is you'll have to reduce the count of this. So the item of type 1 will be reduced to 1. Now on the 5th day you have item 1 only, which is 2. So in this case, if you see, you have discarded only one element, which is this element, item of type 1. So your answer is 1 in this case. Okay. Let's try to take this example. 1 2 3 3 3 4. These are the arrivals, and W is 3, M is 2. So again, your window has to be less than or equals to 3. On first day you are taking one item and its frequency is 1. On day 2 on day 2 your item is 2 and its frequency is 1. When you're considering on day 3, so yeah, window size 3, that is fine. You are getting item of type 3, so you are storing its frequency. When you are moving to day 4, but before moving to day 4, you will have to remove the item of type 1, which is going to be 0, and your window size 3, and whenever you are putting that this element, like the present element whatever is there in the map, its value is 1, which is lesser than m, so then you can take that. So you are taking, that's fine. When you're moving again to the next day, so this item you will have to remove the previous day, so this will move to, this will be 0. And now when you're taking window size 3, so when you try to take this element, you have already two elements which is equals to m, but if you try to take this item of type 3, so your occurrence of that will be more than m, so you shouldn't be taking this, so you will be discarding this. So your discard is going to be 1. And yeah, when you are moving to the next window, so you will be basically um, removing this. You have removed, you have moved to day 6, 4 you have got, and its frequency is 1. So how many elements you have discarded? You have discarded only one element. So okay, the set point, what I was saying is that I'll be continuing with this only. Okay, so what I'll do is I'll try to take 5, 6, 7, something like that. Okay, so these elements I've taken, and window size is still 3, and m is 2. Okay, so now let's say we have taken 1, its frequency is 1. On day 2 you have taken item of type 2, its frequency is 1. On day 3 you have taken item of type 3, and its frequency is 1. Now since window size is 3, now you'll be moving forward, so the previous window whatever is that you will be decreasing, so it is going to be 0, and you are taking the 3 element, I mean this third. In this particular window you will be taking this element, so its frequency will be 2. Now again when you try to take the 5th day item, so you will be removing the uh, the last item of the window. So the last item of the window, this is basically 2, so you will be decreasing that. And now when you are trying to take this, you have window of size 3, but if you try to take, you will have frequency as 3. You'll have 3 items of type 3, so but your m is 2, so you will be discarding this, right? So you have not taken this. Now when you're moving to next window, so you'll have to decrease this element. You have decreased it, and the 4th element you'll be taking, right? Now again this one you will be decreasing, which is going to be 0, and you will move to the next window, and 5 is the element type that you have taken. Now the interesting comes here. So this element whatever is there, since we have not taken into consideration, you have not put in your unordered map, sorry, yeah, map only basically. So since you have not taken this, which means you have not taken count of this in the map. But if you try to decrease its count, so it is going to be -1, which indicates false, like you either have at least 0 element or more than 0 element, you cannot have negative element, right? So which means for this element I have not considered in my map. So whenever the discarded element whatever is there, for that I'll not be decreasing the map, the count of in the map. So how do you keep track of if that element was discarded or if that element was taken? So for that I'll be taking a set data structure, and in that I'll be storing its index. Whenever we are at the index 5, which means that element was not taken. So when I have window of size 3 and I want to take 8th day element, so when I'm removing the 5th day element, I'm checking if that element was taken into consideration or not. Since it was not taken because it belongs to a set, so I'll not be decreasing the count. When I'm moving forward, you have got 6, item 6, and its frequency is 1. So that is the point that I wanted to stretch actually. Whenever the discarded element, or you basically discarded element, you have not taken into consideration, so we'll not be taking that. I think you guys are clear now. Let's try to code it up. So first thing first, what I'll be doing is we'll be taking n as the days, because we have n days, and we'll take integer discard will take. Okay, so which means 0 elements are discarded, discarded right now. We can take elements discarded, which is 0, and we will run a loop from I is equal to 0 to I less than w, which means we still your window size is not w, So your window size will increase from 1 to 3 till w. So this is the for loop that I'll be taking. And in the next for loop, your since you have got our window size w, so now this window will have to move towards right. So your I will start from w, I less than n, I plus plus. So when you have you're building a window of size w, so in that case you will be basically checking if this you'll be taking one map. Let me take here unordered map of type int, and frequency is also int mpp. Also I'll be taking unordered set to keep track of what are the elements that were discarded. So I'll be storing the index here. So first thing first, what I'll do is I'll check if that map, I mean this arrivals of I, which means this item is present, the frequency of that item is less than map or not. If it is less than map, then only I'll be taking that element into my map. Means I'll be considering that, I'll not be discarding that. So I've considered that element, else it was, let's say m, so you will not be taking that, because the frequency of those element has to be at most m, not more than that. So in that case you are going to discard that. So when you are discarding, which means one element you have discarded, elements discard, that will be increased by 1, and now you will have to store the index of that, the element which have discarded. Why you will be storing that instead, I mean storing the index, I'll be telling you, don't worry. So this for loop, what it will do is it will build a window of size from 1 till w. So now when you come at this position, you have window size of w. So which means now the window size, the leftmost element of the window, you'll have to discard, I mean you'll have to leave that, right, because you're taking a window of size w. When you're moving your window, so this element you will be leaving. So for that, what you're doing is you'll be checking if st.find this the last element of window will be I minus w, because let's say you have window of w and the last element is going to be I minus w. Let's say how do I say this, so let's say you have w as 3, and this for loop will make sure that your elements will contain from 0 1 2. When you are at this position, which means your element will start from 3 till n, right, 3 till n. Now when you're taking the third element, so you'll have to discard this 0th element, right, and when you're at the 4th index, you'll have to discard the first index, right. So when you are at the 3rd index, so how do you discard, which is like you will take I and then you will be subtracting with the window size. So it's like I is at this position I is 3 and you subtract with the window size which is 3, so I minus w will give you 0. So you will be discarding this element, 0th element. So I think this is clear. Now you will have to find if that element, if the index is present in the your discarded set. So in that case your map shouldn't be doing anything, which means the frequency of that element should not be decreasing. If that is not present in the set, which means that element was considered into my window, so I'll have to decrease its count. Which will be I minus w. We are decreasing its count. We have decreased its counts. Now the next no, when you have decreased the elements, your window size is w minus 1, but you'll have to take the window size as w. So now you'll be checking if mpp of arrivals of I is lesser than m, so not n, m. So in that case you will be taking that element. else, which means you have frequency as m, so you can't take that element. So in that case your elements, discarded elements will be increased by 1 and you will be inserting into your this set. When you come out of the loop, you have the elements that were discarded. So let's try to run it. So yeah, it got accepted. Let's try to submit it. It got accepted. So in this way, you got to easily solve the problem, and the code is here. I think you guys understood what I was trying to say actually. So this for loop is basically taking care of creating a window of size w, and once you have the window of size w, now your window size shouldn't be decreasing, you should be moving forward. So when you're moving forward, the leftmost element of the window has to be get rid of, and the next element of the window you're going to take when you have get rid of the last element, leftmost element. So your window size has decreased to w minus 1, but you'll have to take window size as w. So yeah, this will take care. And whenever discarding the element, put that, keep track of that those elements in your set by inserting its index, so that whenever when you are discarding the leftmost element, it may happen that the discarded element you may decrease its count, but since the elements you have not taken, so in that case you should not be decreasing the count of that item occurrence. So yeah, I think this is very clear, and if you try to analyze the time complexity, it is taking O of w and this is taking n minus w, so together it is taking O of O of n, which is linear. And if you try to see the space complexity, so this map is going to store the elements. Okay, so like whenever the occurrence of element is 0, in that case I'm not deleting, which means this is again O of n, but we can make this as O of w. So yeah, like both space and time complexity is linear. So thank you guys for watching the video.